Hey folks, Mr. Dell here. We are looking at a box plot and some data and doing some interpretation of that box plot and then actually creating a new one given additional data. So this is coming from CPM's course 2 and this is section 716, 7.1.6, number 7-74. So I'll read it and we'll go from there. Mount Rose Middle School collected canned foods to donate to a local charity. Each classroom kept track of how many cans it collected. The number of cans in each room were, and then I've got my list of, so one of the classes had 107, another class had 55, another class had 39, and so on and so forth. The principal displayed the data in the box plot below. So here's my box plot of the data. Okay. So it asks a couple questions. It asks a question about the interquartile range. So let's review a box plot. First of all, there's some key numbers in this box plot, right? If I take and look at my data here and put it in consecutive order and then find the median, well, that right there, the median is always that center line, right? Or that line within the box is the median. Okay, that would be the median. Then I would take and if I took the first half of the data and found its center, its middle, that would be known as this number here, which is known as the uh, first quartile. Okay, first quartile. And then this right here would be the third quartile, that number. So we have 62 and 80. 80 is the third quartile, is what that's known as. Okay, so, and again, that's the middle of the top half of data, middle of the bottom half of the data. Then our last numbers here, this first number there is your lowest number, right? Or your smallest, lowest number. And then that number always in your data list is your highest or largest, highest number. So that's the five important pieces of data within interpreting a box plot, right? So when it says the interquartile range, and by the way, interquartile range, you might see it IQR, that's the abbreviation, interquartile range, okay, is wanting to know the distance between the first quartile and the third quartile. It's that length of that box. So if my first quartile is at 62 and my third quartile is at 80, I want to know the distance. How far is that? And the math here really is just taking 80 minus 62, the third quartile minus the first quartile. And so we get a total of 18. So the IQR is 18 for this set of data. Okay, let's keep going. So now the main office staff collected, so we've got additional data now. The main office staff collected 55 cans. The counseling staff collected 89 cans. The custodial staff collected 67 cans. So I now have 3 additional data points. And so part C says make a new box plot that includes this data, clearly labeled the median, the first and third quartiles. Okay, so that means now I'm going to have to take my new data plus the original data and list it in order. So I'll just start with my sum all this is 39. And as I go, I usually cross off the data so I don't lose track. Then it looks like the next one would be 55. Oop, and then cross that off. And then I have another 55. This one here, one of the new ones, the office staff. Okay. And then let's see, next one, 62. Then 65. And then this one here, 67. And then looks like 70. And then 77. And looks like 79. 80. And then 86. 80, 86. And 89 now, the new data. And last one, I think, yep, is 107. Okay. So with that data now, I've got to find my 5 major parts of a box plot and then make my box plot, right? So my first is my median, which is the middle, right? So I work my way in to find the middle of the data. So it looks like I have here, my middle of my data is 70, right? Let's check that again. So we go in 39, 89, 86, 55, just to double check. Yep. So that middle of that data, that right there is the median, right? So that is the median. Okay. Then I take my data to find the middle of this data. So the middle of the bottom half, don't include the median when I count. The middle of the bottom half is the first quartile. So if I count in to find where I'm at, I've got these two sets of data in the middle. So I got to find the middle of that. Okay, and that's going to be my Q1 or my first quartile. So to find the middle of that, we've got to find the average. We add the two numbers and divide by 2. Right? To find that, we're going to take 55 plus 62 and then divide that by 2, the middle of those two pieces. So if we do that, that would be, let's see, 55 plus 62 divided by 2. Uh-oh, hang on, 55. 58.5. And then the middle of this looks like it's going to be in between 80 and 86. So again, so this is my Q3. And we can add those and divide by 2. I believe we're going to get 83. Okay. So now I've got my pieces of data. And then the other one is my lowest number is important and my highest number is important. So now I'm going to make a new box plot. So I'm going to have my number line. It's always nice to have a number line so you have what you're dealing with. And I'll just kind of copy their same kind of number line there. So I'm going to have 30, then 40, 50, 60, 70, 80, 90, 100, and 110. Okay, so we start with the median. Median's at 70, so that's going to be the middle of my box, right? And I'll usually try to label the number, so that's my median. Then my first quartile is at 58.5, which is probably right around here. So that now I would connect those to create that bottom half of the box. So that's 58.5 is my first quartile. My third quartile is at 83. So if I find 83, which it looks like maybe right about here on my number line, so there's 83 is my third quartile. Then I need my ends, right? My smallest number is 39. 39 would be right about there. So you just do a smaller line and a little whisker, if you will. And then as well, going to 107, which is probably right about here on my number line. And I'll label it 107. So that right there now, that's the new box plot based on the additional data I was given. Okay, here we go.